Hello, welcome to our channel for probability and statistics. In this video, we will talk about f-distribution and f-test. So what is f-distribution? Actually, f-distribution is connected with chi-square distribution. So if two independent random variables follows chi-square distribution with n and m degrees of freedom, so chi-square n, chi-square m, then the ratio of these two random variable divided by its degrees of freedom, this statistic f and m will follow f distribution with n and m degrees of freedom. And chi-square distribution connected with standard normal distribution. So if a random variable has standard normal distribution with 0 and 1/4 mean and standard deviation, then x square, so this random variable's square will follow a chi-square distribution with 1 degrees of freedom. So if we look at these two curves, both have f distribution. So this is critical value. We say f alpha and m. Why we call this alpha? Because this critical value will leave the area to the right equals alpha under this probability density curve. And the same as this one. And this is for the two sides. So here is half alpha and here is also half alpha. So you can see the f distribution, all the possible random variable is at the positive side. No negative value for the f distribution because f distribution is connected with two chi-square distribution variables division. And the chi-square distribution is a square. Its random variable is the square of a standard normal distribution. So all chi-square distribution has a positive value, right? So f distribution also has positive value. No negative available value for an f distribution. So this is the idea of the test or f-test. If we find the critical value, either it is a one-sided or two-sided f critical value. If we get the sample f statistic, this comes from the sample. So if we comes from the data, this f test larger than this critical value, so we will say the test is significant if we assume there is equal variance in hypothesis testing. So we will talk about hypothesis testing later. So first we have to know if we in a one-sided test, if we get the sample statistic larger than the critical value, then we will reject null hypothesis and we will accept the H1 alternative hypothesis, say that one variance is larger than the other, right? So this is two-sided test. If we get a critical value from a sample in these two, either this white area or this white area, so say if we either get less than this critical value or larger than this one, then the test will be significant. And similarly, if for the one-sided test, if we locate it in this area, we will say test is significant. And the widely used for f distribution is f-test. And the typical example for the f-test is hypothesis testing of comparing two variants. So say consider the problem of testing the equality of two variants, sigma 1 square and sigma 2 square of two populations. So we get So we get the null hypothesis H0 that sigma 1 square equals sigma 2 square. And for two alternative hypothesis H1 is sigma 1 square not equal to sigma 2 square. And for the one-sided test, either is sigma 1 square less than sigma 2 square or sigma 1 square larger than 2 sigma square, right? So we get sample data. Sample take n1 sides and n2 sides from both sample. Then we get the sample variance S1 square and S2 square. Then the sample F statistic equals the division of these two items. So this F will follow F distribution with n1 minus 1 and n2 minus 1 degrees of freedom if the null hypothesis, these two sigma square equal. So under this null hypothesis, if these two are the same, then the sample statistic F will follow F distribution with n minus 1 and n2 minus 1 degrees of freedom. So if we follow this route, get F statistic located in the critical region, then we will reject the null hypothesis. Because this is a very small probability event occurred. So we will reject the null hypothesis that the two sigma square will be the same. So we take an example. Here for the sample 1, get average 85 and standard deviation 4. Sample 2, give an average 81 and a standard deviation of 5. So the question is, if we assume that the two unknown populations are equal, can we justify in making this assumption with alpha level of significance? And the solution is, if we assume these two population sigma square equal, and we form alternative hypothesis H1 sigma square 1 not equal to sigma square 2, and we set alpha 0.1. So which means this is two-sided test, and we will get two critical value. One is F half alpha 0.05 with 2 degrees of freedom, and we can find this one from the F distribution table, which is 3.11. And we will also get a critical value called F 0.95, 11.9 degrees of freedom, and this actually can be get from this formula and equals 0.34. So if we from the sample data F, which is the division of sample variance for two sample, right? If this one is either less than this value or larger than this value, then we say the test will be significant and will reject this null hypothesis. And you can see here we get the sample 1 square 16 and the sample 2 square 25. Then the value is 0.64. So because 0.64 in this central area, not in the critical region, right? So we will not reject H0 and say we can conclude that there is insufficient evidence say that these two variants differ. Or say we will hold the null hypothesis, or say that the two population variants equal, right? Thanks for watching.